Here's our 2.2 notes. We're going to talk about what makes something a function if it is in an equation form. And then we're going to talk about graphing piecewise functions, okay? So I'm switched your notes up a little bit. These are the last two slides of your notes. I'm doing them first, and then we'll do the first two slides last. So if you guys notice, right, it says here the rules of a function. We talked about the rules of all of our domain and stuff, right, a couple days ago. And there was 3 rules we couldn't break. Can't have a variable in the denominator. You can't have a variable underneath the square root. I mean, you can, but you have to set it greater than or equal to 0. And then a square root in a denominator is greater than 0. So we have some rules for functions. All right, if you guys had a graph, and I think some of you have seen this before, some of you may have not, but just say you have a graph, right? And this picture looks like this, and this picture looks like that. The one on the left, we'll call it A. Is A a function? Yes or no? Is B a function? So you guys are telling me yes to A and what to B? No. Why? You're right, but why? Do you guys remember the vertical line test? If you draw a vertical line and it only touches a function one time, or a graph one time, then yes, it's a function. If at any point in that graph you can draw a vertical line and it hits twice, then it's not a function. So that would be graphically how we would figure that out. If you're given a set of points, like so I have A here, let's say I have -1, 0, 2, 1, -1, 1, and 3, 2. And I have B, 1, 2, 3, 4, -5, 6. All right. Is A a function or is B a function? Which one? Which one is a function? Compare A and B. What do you notice? Look at A. Look at your X values. Do you see how you have a -1 that repeats? That means if you were to graph it, you would have a vertical line that touches -1 2 times. So A is not a function because it has X's that repeat. B is a function because the X's don't repeat, okay? So if you're given an equation, you'll be given about probably 2 or 3 of these on your tests. Super easy, super basic, but if you get it wrong, there's no partial credit. It says you can determine if an equation is defined. It says, does the equation define y as a function of x? You can determine this. Every equation is a function unless y is raised to an even power or it's in an absolute value. So as you will work through this, you guys will have these questions, and I expect them to be answered like this on the test. If they're not, you're not going to get credit. So make sure you're paying attention. The only thing that matters is our y value. So I look at letter A and I say, okay, here is y. Read the two reasons that make it not a function. Is y raised to an even power? Yes or no? Is y to the first, is that an even power or an odd power? Y to the first power, guys, what is that? Odd. So no, it's not raised to an even power. Is y inside of an absolute value? No. So you would tell me on this one, yes, this is a function. Not just yes or no, not y and n. You would say, yes, this is a function. All right, so look at number 2. Y, it's the only thing that matters. What are the 2 rules you can't break? First thing, is y raised to an even power? Yes or no? Yes. So this, you would tell me no, and then you have to tell me the reason. And you would tell me because y is raised to an even power. Last period, someone was like, oh, well, you can't because it's raised, not it, because x is raised to an even power as well, and that's okay. You have to tell me the reason, and it's all based upon y. So you would tell me no because y is raised to an even power. So look at C. Is y raised to an even power? No. Is y inside of an absolute value? No. So you would say, yes, this is a function. Any questions? Anyone have any questions? All right, look at D. Is y raised to an even power? Yes, so your answer here would be no, and you would tell me because y is raised to an even power. Look at letter E. Function, yes or no? Is y raised to an even power? No. Is y inside of an absolute value? Yes, so you would tell me this is not a function because y is inside absolute value. Now, if you get that question wrong on a test or a quiz, it's just because you don't know the two rules. So you've got to make sure that those easy gimme questions, guys, you know how to answer them and to answer them properly. Good? We okay? All right, good talk. All right, next thing we're going to talk about is piecewise function. All right, I'm going to do 2 of these with you, and then you guys are going to do these on your own. You're going to practice them. A piecewise graph. We talked yesterday about how to evaluate a piecewise. We talked about finding your parameters, your boundary lines, where you have to look for which equation. A piecewise function is just a series of graphs that you guys are going to plot points and put on your coordinate plane. But you're going to then look at your boundaries because you only want a certain part of that graph. So if you notice in this first example, first of all, f of x is just a fancy way of saying y. And you have a parabola and you have a line here. So if I have x squared, all right, we're going to pick some points to the left and to the right of 0 to evaluate this. So I'm going to say -2, -1, 0, 1, and 2. All right, when I plug in -2 to x squared, I get out +4. When I plug -1 into x squared, I get +1. When I plug 0 into x squared, I get 0. When I plug 1 into x squared, I get 1. And when I plug 2 into x squared, I get 4. Questions? All right, so let's plot these points. I'm going to say -2, 4, so -2, 1, 2, 3, 4. -1, 1. It's kind of not on the point. -1, 1, 0, 0, 1, 1, and then 2, 4. And as I draw my parabola, I know it's a nice smooth curve. You guys notice I'm going to use like dotted lines. You can use little dots, whatever. I want you guys to do that. And you're welcome to use my color pencils on the test or quiz because you have to be able to erase. All right. Now is the point where this comes into play. This inequality says x is greater than or equal, less than or equal to 1. So whatever this boundary line is, you're going to draw your vertical line right here where x is 1. Now this equation, this piece of the piecewise wants everything that is less than or equal to 1. So where are the values on the x-axis less than or equal to 1? To the left or to the right? To the left. Very good. So what this is telling you is everything from this point, this line over here, they want you to keep. And then they want you to erase everything else. You just want just that piece. So you erase everything else. And then one more thing that you have to look at. What kind of a dot should I have right here? What kind of a dot? Closed. Make sure that I know it's closed. So that's just the one little piece of the graph that I wanted. Now the second one says y equals 2x plus 1. So this is a line. My slope is 2 over 1. And my y-intercept is at +1, right? This is a positive line, so it's going to go upwards. So at 1, I'm going to put a dot, and I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and so on. And I'm going to make my line with, again, my dashed dots, however you want to say it. And now I look at this boundary line. Again, what is my boundary line? Where am I looking to the left and right of? +1. So it says I want all the values that are greater than 1. Which way on the x-axis are all of the values greater than 1? To the left or to the right? To the left or to the right? Okay, to the right. So what kind of a dot am I going to have right here if it's just greater than? We're going to have an open dot at 1. So I'm going to draw a nice big open dot so you guys know it's open, and I want all this stuff over here. And then what do I do with all of the stuff that I don't need anymore? I need to erase it. I need to get rid of it. Do you see the two pieces of the graph that they want you to have? Yes and no. Do you see how one is included, one is not included? You see the values to the right that you want, you see the values to the left that you want. These questions are not incredibly difficult, they're just time consuming. So you got to make sure that you guys are paying attention to what you're doing, you're taking your time, and that you know how to graph stuff. All right, if we look at the next one, first of all, I want you to change this for me, please. Take off that or equal to in your second equation. If you notice here, guys, we have 3 different equations. You have 3 different lines. I know they're all lines because all the y's are to the first power. So I first have y equals negative 4x plus 3. My slope is negative 4 over 1, so it's a downward line. And my y-intercept is at 3. So I'm going to go up here. I'm going to go up to 3. And my slope is 1, 2, 3, 4 over 1. 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 Okay, it goes a little off the graph. No big deal. You guys can handle that. And then we have our dotted lines. We've got to see where we're looking, to the left or the right of our boundary line. And our boundary line right here is negative 1. So I'm going to go to negative 1. I'm going to draw my vertical line. And it says I want all the values that are less than negative 1. So all of the values that are less than negative 1 are to the left of that vertical line. So I want to keep all of this stuff over here, and I want to erase everything else. And what kind of a dot do I have at negative 1? I'm going to have an open dot because it is not included. So then what do we do with everything else? You erase it. Okay. So now I look at my next equation. It says 1/2 x y equals 1/2 x. Guys, if you don't have the 1/2 in front, it might look like this. Understand that there's a 1 right here. So your slope is 1 over 2, and your y-intercept is at negative 1. So it's a positive line sloping upwards. So I'm going to go to negative 1. I forgot to erase right there. I'm going to go to negative 1, and then my slope is up 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2, and so on. So here's my line. And again, you guys are welcome to use my color pencils and stuff on the test. Now I look at my parameters. Where are they telling me I have to look? In between what? In between x is negative 1 and in between where x is 3. So what part of this line am I going to keep? The stuff in the middle or the stuff on the outsides? The stuff in the middle. And I'm going to have open dots at both of those boundary lines because it's not included. So that's the piece I'm going to keep. And then what do I do with everything else? We're going to erase. All right, this last one can be a little bit tricky. FG got it no problem, but I period had a little bit of an issue with it. Guys, f of x, remember, is a fancy way of saying y. So this says y equals 3. What kind of a line is y equals 3? It's a horizontal line right here. It goes right through where the y value is 3. So now I look and I say, okay, well, where should I look? To the left or to the right? And at what number? So I'm at 3, because that's what it says right here. X is greater than or equal to. So I know at 3 I'm going to have a solid dot because it says or equal to. And now I want all the values that are greater than. Well, over here are all the values on the x-axis that are greater than 3. So that means I want to keep everything to the right, and I want to do what with everything to the left? What do I do with everything to the left? I'm going to erase it. So there, guys, you have created your piecewise function with all 3 of these functions. All piecewise is taking little pieces of each function that you graph, and you have to look at your, we call it your parameters or your boundary lines. These tell you right here, hold on. These inequalities right here tell you which way to shade, which part of the line you want, and what your boundaries look like, whether they're open or closed dots.